This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 1, Lesson 6, Adiabatic mixing of two Airstreams. A mixing box brings two streams together, typically return air and outdoor air, with no heat added and no work done. The result is a mass-weighted average of the two inlets. On the psychrometric chart, the mixed state falls right on the straight line between them, split inversely by mass flow. We'll set the three balances, work one return plus outdoor mix, and locate the point with the lever rule. Concept 1. The three balances. Two streams in, one out, no heat added. Dry air is conserved, moisture is conserved, and energy is conserved. Solve the moisture and energy balances, and each mixed property is just a mass-weighted average of the two inlets. The humidity ratio and the enthalpy of the mix sit between the two, pulled toward whichever stream carries more mass. Concept 2. The dry bulb. Strictly, the handbook conserves enthalpy, not temperature, but moist air enthalpy is almost linear in dry bulb. So for standard air, the energy balance reduces to the very same mass weighting on temperature. It's a fast estimate, and in our example it lands on the same 80 degrees as the full enthalpy balance. Concept 3. The lever rule. Draw the two states on the chart, and the mix sits on the straight line between them. The catch is the direction. The segment next to a state is proportional to the other stream's mass flow, so the mixed point lands closer to the larger stream. 3 parts return and 1 part outdoor puts the mix a quarter of the way over from the return state. One caution before the numbers. The balance is weight by dry air mass flow, not volume. Airflow usually comes in CFM, and at equal conditions, the CFM ratio matches the mass ratio, so weighting by CFM is fine. But when the streams differ in density, from a big temperature gap or from altitude, the warmer, lighter stream carries less mass than its CFM implies. Setup. A mixing box blends 3000 CFM of return air at 75 and 50%, with 1000 CFM of outdoor air at 95 and 40%, 4000 CFM total. The humidity ratios come off the sea level chart. The streams are close in density, so we weight by CFM. Find the mixed temperature, then locate the state. Solve. Part 1. The mixed temperature. Weight the dry bulbs by airflow. 3 parts at 75, 1 part at 95, giving 80 degrees. The humidity ratio weights the same way, to about 0.0104, and the full enthalpy balance returns 80 as well. The two routes agree, so the temperature shortcut holds. Solve. Part 2. Locate the mix. The lever rule. Outdoor minus mix over mix minus return is 15/5, which is 3, the mass flow ratio. So the mix sits 1/4 of the way along the line from the return state, closest to the bigger stream. Read the chart at 80 degrees and 0.0104. Relative humidity about 48%. Traps. 5. 1. Only mass, moisture, and enthalpy are conserved. Never average relative humidity or volume, even when it happens to land close. 2. Weight by mass, not volume. Convert CFM when densities differ. 3. The mix must fall on the line between the states. Off the line means an arithmetic slip. 4. The lever rule points toward the larger stream, so a 3-to-1 mix sits near the return air. 5. Use the same total flow for every average. Quick recall. Mixing conserves dry air, moisture, and energy. 3 balances that make the mixed state a mass-weighted average. It lands on the straight line between the inlets, split inversely by mass flow, so it sits nearer the larger stream. Weight by mass. Use CFM only when densities match, and read relative humidity off the chart at the mixed point. Golden rule. Average the conserved quantities, plot on the line, let the lever rule pull toward the bigger stream. Next up, Lesson 7, Evaporative cooling. Mixing rode a straight line between two states. Evaporative cooling rides a line of nearly constant wet bulb, trading sensible heat for latent as water evaporates and the air moves towards saturation. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.